Hello guys, there's an announcement regarding this midterm test. So spend some time to read and ask if, let's say, you have any question. Recommendations for dinner after class? After which class? After 7:30 class? Anywhere? Okay, so the announcement about this midterm test, it is going to be open book online test. The test duration will be around 3 hours. The test will be available on My Times for 1 week. So whenever you feel like doing it, just launch the test and do it, okay? At your own time. You can do it on during midnight also, yeah? Up to you. As long as you have that 3 hours window for that. Only one attempt per person. So for any reattempt, you will have to contact me and I will remove 2 marks out of the full 10% at the end of the reattempt, okay? Topics covered: EDA, regression, bias and variance. How am I doing today? I am doing good. Having some anxiety regarding job security. Recently, our company has a structure reorg, and I am very worried of layoff. CV NLP literature review, is it 8 to 10 or must at least 10? 8 to 10. Metadata include all the dataset variables inside. I don't understand what you mean. Okay, so those who just came in, spend some time to look at the announcement regarding this midterm test, yeah? Is practical conducted in LT today? So where would you like to have the practical class? Depends on you. Can I use I in mlpc individual assignment? Preferable the more formal way of representing. Hello. First time 0 over 10, second time 10 over 10, I will have how many marks? No, you won't be allowed to have second attempt. Everybody have one attempt only unless you encounter any technical issues. I will only mark the latest attempt. Can my report be 30 pages long? Why would it be that long? Can, but why? Can you tell me why? LT1, yes, let's have our practical later at LT1. Is coding part of the midterm going to be long lines of code or just a single line of code for the question asked? Well, there are some questions where you need to write some code and generate the output so that you could answer the questions. So is that long lines or short lines? I'm not sure. Yeah? Yes, so hello everyone, welcome back. It is week 5 today, and I have an announcement regarding the midterm test to make before the class today. So your midterm test is going to be an open book online test. So everything will be submitted through My Times, and the test duration for this midterm test is 3 hours. So the test will be available on My Times from 1st of June to 9th of June. Yeah, so feel free to attempt anytime you like within the week. Okay, you can do it at your own time. Make sure that you have that 3 hours, you free out that 3 hours for this test. Okay, everyone will be only allowed one attempt. So any reattempt will be granted unless you have any technical issues during the test. Yeah, in the case of reattempt, I will only mark the latest attempt. I will not mark the first attempt. Okay. The topics covered will be EDA, both theory and code, regression, both theory and code, as well as bias and variance, a topic that we will cover today. Okay. So if let's say you have any question regarding the test, please post it on the WhatsApp group chat. So for those who haven't joined the WhatsApp group chat, and if you don't want to miss out anything, please use the link provided in My Times to join the group chat. Yeah? Okay, is there any question? Is that turn it in for the midterm? I don't think so. Okay. So is the coding part, the midterm, going to be long lines of code or just a single code for the question asked? So you will be asked, you won't be asked, so you may be required to write some code to answer certain question. So it should be several short lines of code. Are we typing the code inside? Also need collab? Yes, also need collab. How many questions will there be for midterm? Around 5 to 6. It's only 10 marks, right? Do we do it in words or My Times? My Times. Approximately how long do you prefer for the individual assignment report? 15 pages max. How many pages will the answer have to be for the midterm? Short lines of answers. Yeah, so I will only mark the second attempt, the latest attempt. Okay. Any more questions regarding the midterm test? I'll take it, how many questions in total? 5 to 6? It's only 10 marks, right? What should be written in data prep if my data set don't have to use techniques like SMOD? You don't have to write anything. Okay. Is it expected the whole 3 hours will be taken? Depends on your skills. Any objective question? Not so likely. Follow the instruction from the question. Do we copy and paste from Colab to My Times, or do we screenshot? Follow the instruction from the question itself. Okay? Yeah? So, with that, in case you have any other question, so please feel free to post your question on the WhatsApp group chat, so to maintain fairness to everyone, so everyone can benefit from your question as well. Yeah? Okay, so without further ado, let's start our lecture today. So a little bit recap of what we discussed last week. So last week we discussed about the first machine learning algorithm in our entire module, which is regression. So regression is really about fitting a line to the dots, right? And we see how do we allow these algorithms to calculate the residuals to find the best fit line that crosses all the data points that it has seen, that we have in our data set. So we discussed 2 types of regression models. First type is linear regression. Another type is multiple linear regression, where we include multiple features instead of just one feature. Yeah. Then before we end the class, we also discussed about the model performance matrix, which are the MAE, MSE, RMSE, and also the R-square. So this is what we have discussed so far. And is that all for regression? In the those who have already attended the lab session, we have seen the entire pipeline of building a regression model, right? But is that all? So today we are going to talk about another 2 topics that is very related to this regression model, that is called polynomial regression and also regularization. So now these 2 concepts is very important in machine learning model, in the sense that it is helping us to address an issue, 2 issues which we commonly encounter in building machine learning model. So the 2 issues here are overfitting and also underfitting. So the underlying concepts of overfitting and underfitting has a lot to do with bias and variance. Therefore, we are going to start our lecture by talking about bias and variance, polynomial regression, then followed by regularization. So in terms of regularization, we will come to more types of regularization in classification model later on. But today, we will focus on the regularization, which is relevant to regression models, which are Ridge and lasso regression. Yeah. So now today's topic is about addressing a topic which is called generalization. So machine learning is really all about generalization. How do we train a model using our historical data and assuming that it will work on our future instances? Therefore, we have to make sure that these models are generalizable to future data which this model have not seen before. Yeah? So it is really important because this will define how well our model will make prediction or make decision on behalf of human. So let's first start with bias and variance, some terminology. So this bias, what is this bias and variance? So bias is an error that occurs because of the assumption that is being made by our model. So bias is an error term. And this error comes from the assumption that is made by the model. So say, for example, if we use linear regression model. So basically, this model will assume a linear relationship between our features and our target. So is there any error that arises from this assumption? So if there is any, that would be considered as bias. Yeah. So the next the next error term that we want to discuss today is called the variance. So variance is the type of error that occurs because of the sensitivity of the model to our training data. Yeah. So whenever we discuss these error terms, bias and variance, it always comes with a certain magnitude. Bias can be high and bias can be low. Same to variance. Variance can also be high and can also be low. So this bias and variance is a very important concept in machine learning, and it is often used or presented in a graph of error versus model complexity. So on the x-axis, what you will see here is the model complexity, and on the y-axis is the level of error. And you can see from this chart that there are two dotted lines, which refers to the bias and the variance. Yeah? And the solid line here refers to the general error. So in the next slide, what we will discuss are three of the situations where the situation has high bias and low variance, high variance, and low bias. Yeah? So both of these cannot coexist. Yeah? So now let's start with the first situation here, which is high bias. So whenever we have high bias, the error model complexity chart always start with the condition where we have high bias. So in the case where we have high bias, we know that this bias is the error that is arising from the model assumption. So whenever we have high bias, it means that we are using a wrong assumption to assume the trend of our features to our target, and therefore we have very low variance and high bias. So this happens, whenever this situation happens, it is a situation called underfitting. So this underfitting happens when the model is too simple and it couldn't capture the actual underlying patterns of the features versus our target in the training data. So this situation arises whenever we see a high bias and low variance. High bias because the model underfits the training data, and low variance because it has a simple structure that is too simple, that is not describing how the feature is affecting the target variables. This is a situation of underfitting. So another situation here is overfitting. So in what situation, what kind of situation is considered overfit? So overfit will occur when a model is too complex that it learns from all the data points in our data. So it learns every single trend, which includes the outliers, and memorize the training data too well, including the noises and the outliers. So in this situation, usually what we will encounter is very low bias, and high variance. Low bias because the model is so complex that it describes and fits to the training data too well. High variance because it memorizes all the noise from the data set. Therefore, it causes the model to be ungeneralizable to future unseen examples. Yeah? So now, what is considered a good fit in this sense? So a good fit would be a situation where the bias and variance converge at a point. So there it is a situation when there is a balance between the two extremes of of variance and also bias. So we will consider that situation as the lowest bias possible when the model generalizes well enough to unseen data, and it has low variance when the model captures the patterns in the training data well. And this is the sweet spot of the final model which we are trying to produce. Yeah? So the next part that we want to cover is how do we spot a high bias problem. So a high bias problem is always characterized by high training error and the validation error is in a similar magnitude. Say, for example, if our error is as high as 60%, so then our validation data is also as close as 60%. That is a situation of underfitting. So that is a high bias problem. So why do we consider this situation as a high bias problem? It's because, say for example, we have a trend that is binomial in this case. So now, if we were to simply use a linear regression line and fit it across these dots, it will give us an output with the lowest error possible. But the lowest error that this model or this line has seen may be very, very high when it is taken together. So this is a situation which has a high bias because this bias or this error exists because we have chosen a simple or a wrong model to assume the data pattern. Okay? So this is on underfitting. So how do we decrease this bias situation? So in order to decrease bias, there are a few things that we can do. So the first thing is to increase the number of features that we want in our model. Okay? And the second one is try to train a more complex model. Say, for example, if we are using a neural network base, we will increase the training time to train a more complex model in that sense. Yeah. So what is considered a more complex model in a sense? So a more complex model, in order to achieve that, we can include more features. There is another method which is creating non-linear models. We are talking about regression over here. So how do we create non-linear regression model? Is using a technique called polynomial features. So we'll discuss more about this polynomial feature in the next session. And finally, how do we create a more complex regression model? It's ultimately by using artificial neural network, by increasing the number of hidden layers to decrease bias, by increasing the model complexity. So that is a situation of underfit, and how do we overcome underfitting? So high variance is a more commonly encountered situation. So whenever how do we spot this overfitting? So overfitting is a high variance problem that is characterized by two situations. First one is we will always see very low training error, very low error on the training data set. And it has very high error on the validation and test data set. So this is very commonly a very common issue that we see in actual world. So then, how do we actually reduce the variance? So in order to reduce variance, there are several ways. The first one is increasing the number of training data. So we know that we seldom come to the luxury of having more training data, so that in the case where we don't have a lot of training data, then how can we address this overfitting issue is probably we can try to reduce the number of features, or increase regularization. So regularization is a technique that we'll go over in the later session also. So what is regularization? As in regression, there are two types of regression that regularization technique, which we will go through and take a look at towards the end of today's session. Yeah. So now, as a summary of what we just talked about, we just talked about two error terms, bias and variance. One which is arise from how the model has made an assumption, and high variance is a situation that we encounter, is another situation that we usually encounter. So whenever we have a high bias, we know that our model is underfit, and whenever we have high variance, we know that our model is overfit. Yeah? So is there any questions so far regarding bias and variance? No question. Okay, so quick question. True or false? So as more variables are added to a model, both its complexity and variance generally increase. Is that true or false? That's true. So as we include more and more variables or features to our model, we are trying to increase the model complexity, and therefore the variance will increase. It is describing or fitting our data points better. So model adjustment that decrease bias also decrease variance. So this situation lead to a bias variance trade-off. Is that true or false? The answer is false, because bias and variance never increase in the same direction. As bias decrease, variance increase. As variance decrease, bias increase. Okay? So the next topic that we want to talk about is polynomial regression. So polynomial regression is a type of technique that is helping us to increase the model complexity to model on nonlinear relationship. So last week, what we have talked about is assuming that all the data in the world is linear, is in a linear relationship, and hence we have simple linear model and also multiple linear regression models. So now, how do we make this linear model to become to fit to a non-linear data pattern, which is more realistic to today's data problem or data trend? Yeah, so this is about polynomial question. So just a quick check before we proceed. Polynomial regression is a way to decrease bias or decrease variance. Decrease bias. Okay, so now polynomial regression is a way to decrease bias by allowing this linear regression model to capture high order features. Okay, so by how? By adding some polynomial features. So what is polynomial feature? So let's just start with looking at the case study of what we discussed last week. So last week we discussed a case study of the budget availability and the box office revenue. So we see that this is roughly the data pattern, and we try to fit a linear regression line that says y equals to b naught plus beta 1 x. Yeah. So we are using this marketing budget as as our variable to predict the revenue. So now, as we plot one chart over here, we sort of see that it is not a very ideal fit, because there are a lot of points that is falling out of the line, that is very far from the line itself. So now, if we were to draw a curved line over, it seems like we are fitting to more and more data points more closely. So now, how do we turn this straight line into a line that is curved? So by adding polynomial feature. So polynomial features are features that has a power to it. Yeah. So it depends on how many degree of polynomial features do we add. It is able to create this curved line, another type of curved line, so far and so forth. So it depends on the degree which we have to optimize and find out. Yeah. So just a recap on what have we discussed earlier. A linear regression means a linear combination of features. So now, by adding this polynomial feature into our linear regression equation, we are trying to create new features from the existing features. So then, which can be used to capture nonlinear relationship. Yeah. So bear in mind that here, our algorithm still remain very linear, even though we have added in new features that are non-linear to capture this interesting relationship within the data points. Yeah. So now say for example here, we are adding x squared to capture the non-linear relationship between the feature and also our target. Okay. So adjusting to this standard linear approach by adding this polynomial feature is one of the many approaches to address this non-linear relationship. Yeah. So it is one of the alternatives before we explore using neural network to address our regression problem. Okay. So in terms of Python execution for this polynomial regression, this next week we will talk about using grid search to find out what is the best polynomial degree that fits to our data set. Yeah. So as a summary of what polynomial regression is a way to increase model complexity so that we could capture non-linearity and reduce bias. Yeah? So how do we increase the model complexity is creating additional feature based on the current feature which we use. Say for example, if let's say we have a feature x, then we will create additional polynomial features such as x, the square of x, to capture a binomial data pattern. Okay? Question? Polynomial regression increase the model variance. True or false? A. It's true. It increases the model complexity, therefore increase the model variance. Okay, it fits better to our data points. Correct? Yeah? So, before we end the class, we are going to talk about the concept called regularization. So in this sense, what we are trying to do is to reduce the complexity of our regression line to try to prevent overfitting. Yeah? So now there are two methods on regularization for regression. First one is called the lasso, and then another one is called ridge regression. So, just to see if you are still awake, regularization is a way to decrease variance. Okay, so trying to prevent overfitting. So now, before we talk about this regularization, it is a relatively complex idea. So we have, let's just do some recap on our discussion last week, where we mentioned about whenever we try to fit that line using algorithm, what we are trying to do here is to minimize the error function. So how do we get the best fit line using algorithm? So in order to get the line, we have to calculate the residual. And the residual is, in simple terms, the difference between the predicted value and the observed value or the actual value. So say for example, if let's say this is our model, this line is our model, whichever points that is under the line here has a positive residual, because we are taking the predicted value minus of the actual values. And whichever points that is above this value has a negative residuals. And if you still remember, when we talk about this residual, the sum, we are taking the sum of residual of every single line to that predicted value. And because of this positive and negative direction, we talk about a situation where this error will be trade off as we sum up all the values. So then we talk about how we ended up squaring each term to make sure that each of the error term here is positive. And this process gives us the matrix which is called the sum of squared residuals, which is also equivalent to our MSE. Okay. So now, if you were to take this sum of residuals, the mean squared of error, and put it into a mathematical function, so it will look like this. So it is the predicted value minus of the observed value that we have seen earlier, taking the square of it, and the sum of every single line, every single dot to that line. So this will be, it will be written this way. And J is usually a way of us representing the cost function of a particular model. So a cost function J of our coefficient beta naught and also beta 1 is equals to the sum of squared residuals times a coefficient which is 1 over 2m. So this is usually expressed with for the ease of calculation only. We do not have to know why, but this is the cost function of a particular regression model. Yeah. So now, what we want to talk about, what is regularization? So without regularization, an overly complex model you will try to fit to every single dot in our training data. So now, with regularization, what we are trying to achieve here is to make that line more simple. So in a way that it doesn't fit to every single dot in that in our training data. So how do we achieve that is using regularization. So regularization, how do we achieve that is we try to add a regularization term to our loss function. So now say, for example, we have our model error, which is our loss function, which is our cost function or loss function. Then we will add a regularization term to it. So what is this regularization term? So the regularization term involve a lambda, which is called the regularization strength parameter. So now this parameter controls the amount of regularization that we are trying to apply to this model. So a higher lambda value here means that we are trying to create a simpler model with more bias. And if you were to use a relatively lower lambda value, it leads us to a more complex model with more variance. Yeah? So now, this lambda will be considered as one of the hyperparameters. So when we talk about parameter, the parameter of this regression line refers to our beta naught and also beta 1. And this regularization strength over here is considered one of the hyperparameter. And therefore, if we were to do hyperparameter tuning to tune our model, this will be the term which we are trying to tune or fine-tune. Okay, so this is the concept of hyperparameter tuning in building a regression model, because this term technically doesn't exist in our model. It happens behind the model where we are using this lambda term to fine-tune a way of how this algorithm find that best fit line. Okay, so again, this regularization strength, they are trying to add weights to each of the feature. Okay, so now, say for example, we have our cost function. So cost function of every single coefficients that we are trying to find. So what we are trying to do here is to add a certain weight to penalize the error term that we see. Okay, so what are these error terms? There are two types of error terms. First one is called the L2 regularization, or sometimes we call this as ridge regression. So the difference between the two types of regularization is the error or this lambda, which we are trying to add on to the error term. So in terms of L2 regularization, what we are trying to add to every single error term over here is a squared coefficient values. So as much as we add on this additional term to every single error which the model tries to predict, it means that we are trying to moderate every error that it has made will be magnified in a way. So will be magnified by a power of 2. In this case, it will help us to reduce the variance because we are imposing more error or more bias to the error term. Okay, so that is the basic concept. So we can select the best regularization strength using cross-validation. There is no way that we know what is the best regularization unless we run this algorithm to find out the actual term. Yeah. So the next regularization term over here is called the lasso regression, which is L1 regularization. So the difference between lasso regression and the ridge regression is on the error term that it has added to our cost function. So in ridge regression, we have added a squared function of value to that particular cost function. But in the case of lasso regression, what we are trying to add is the absolute value of a certain coefficient. Yeah, so it achieved a similar effect in ridge in terms of the complexity trade-off, but it increases the lambda, raises the bias, but lowers the variance. Okay, so in this case, lasso regression is known to be one of the more effective manner to perform feature selection compared to ridge regression. Yeah, we shall take a look at how it works in next week's practical class. Yeah, so that is on lasso regression. So at the end of this class, what we just discussed on regularization is a method which we use to reduce the complexity of machine learning model. We try to prevent overfitting. L1 regularization lasso is useful for feature selection, whereas ridge regression is more of a way to try to prevent overfitting. Yeah? So is there any questions so far? Now, regularization zeroes out or get model coefficient closer to 0 in such a way it avoids the data being overfitted. Is that true or false? Yes, that's true. So at the end of this class, what we just went over is the concept of bias and variance. So bias and variance are two of the very important error terms when it comes to evaluating machine learning algorithm. Polynomial regression is a way to address an issue which is underfitting. Regularization is a way of addressing a model when we encounter a situation which is overfitting. So is there any question regarding what we have discussed so far? And is there anything that you want me to explain further? Are you clear on the interpretation of the graph? There's a reason why I asked you this question, right? Are you clear on will we learn detailed underfeeding or overfeeding technique? What do you mean? So we learn how to spot them. Do we attempt on achieving equilibrium between bias and variance for a ML model? Yes, we are trying to achieve the equilibrium between bias and variance to decide a model which has a good fit. It's not underfit and not overfit. The evaluation of overfitting is very straightforward. So the two things which you need to decide whether a model overfit is the error when you encounter on the training data and the error which you encounter on validation or test data. Yes, if let's say there's no question, we shall dismiss the class and we shall take some time for the transition between the lecture and practical. So those who are doing practical today, please stay in this lecture hall. Any other question regarding your midterm? Is the whole 3 hours expected to be used? Probably. Depends on how good you are with coding. It's an open book test. It also depends on how fast you flip your book.
对对对。